Namaste. My name is Nikhilesh and I teach artificial intelligence and large language models to senior IT professionals in a very simple language. So today we'll talk about quantization and simplify this very important concept. So before we do that, let me ask you a question. How much computational power is required to train a model like ChatGPT? Even if you don't know the exact answer, you must be knowing that in order to train such a large model, you need lots of computational power. Well, to be exact, it requires 14,000 GB of RAM. So GPT-3 has 175 billion parameters, and in order to build in order to train such a big model, we need 14,000 GB of RAM. So we need to buy multiple GPUs, and which is expensive. Now this is for pre-training. But even if we want to fine-tune such a model, or even if we have to infer such a model, we require lots of computational power and memory, which is beyond the reach of many big organizations. Forget about individuals. So how can we use these models? How can we reduce the memory footprint and the computational power? So this is what we do with quantization. So let's try to understand this. So when we store, so let's say we have 175 billion parameters, and when we store these values, we generally store in floating point 32-bit precision. Now what is FP32? In FP32, we reserve one bit for a sign, 8 bits for exponent, and 23 bits for the remaining of the fraction. This is what FP32 is. Now, what if we try to store the same value in FP16? In FP16, there is 1 bit is for sign, 5 bits are for exponent, and 10 bits are for the exponent. So if we store value of pi in FP32, value would be this 3.141592. But if we try to store the same value of pi in FP16, the value actually becomes 3.140625. So the value slightly reduced, which will obviously hamper our performance. Our accuracy will decrease. But now you can see the computational power has gone down by half. So now we only need half of the computational power to store these weights. However, the performance will be slightly decreased. So if we are okay with this trade-off, and mostly when we can't afford such computational power, we are actually okay with this thing. So here if we want to reduce the memory footprint and the computation, we use quantization technique. Okay, so there are two kinds of quantization: post-training quantization and quantization await training. The name itself, says what exactly. Post-training quantization. In post-training quantization, we basically we store the weights after the training has done. So we basically reduce precision after the training has done. Earlier, while training, we have stored it in FP32. But after that, we stored in either FP16 or bfloat 16 or in integer 18. So this is how we reduce. In quantization await training, we basically quantize the weights during training as well. So here the model is actually learning the quantized weight. The downside of this could be that the training could become complex. But the overall idea is that if we are not concerned about high accuracy or the highest performance, we just need to basically decrease our computational requirement, then we can use quantization. So this is what quantization is. Hope you like the video. I'll discuss another concept in the next video. Thanks for watching this.